Welcome to the Database Marts channel. In this video, we will explore the inference performance of the 3 NVIDIA V100 GPU server under the vLLM framework. We set up the environment using a GitHub project and selected 4 mainstream models from Hugging Face for evaluation. We used a fixed input of 100 tokens and output of 600 tokens, running tests with 50 and 100 concurrent requests respectively. The 3 NVIDIA V100 GPU server is configured as follows. The first model tested was Google's Gemma 3 instruction-tuned version with 4 billion parameters and a model size of 8.1 gigabytes. Under 50 concurrent requests, the processing speed reached 2.64 requests per second, with a total throughput of 1847.72 tokens per second. When concurrency increased to 100, the processing speed rose to 3.54 requests per second, and the total throughput increased to 2,474.98 tokens per second. Overall, the 3 NVIDIA V100 demonstrated stable performance when running such large models, showing solid concurrent processing capability and inference efficiency. The second test used the distilled version of the deepseek-ai Llama model, which has 8 billion parameters and a model size of 15 gigabytes. At 50 concurrent requests, the processing speed was 2.2 requests per second with a throughput of 1,449.06 tokens per second. When concurrency increased to 100, the processing speed rose to 3.18 requests per second, and the throughput increased to 2057.11 tokens per second. Compared to the first model, deepseek-ai showed slightly lower processing speed and throughput due to its larger parameter count and model size. However, it still demonstrated good scalability and stability in a multi-GPU environment, making it suitable for medium to high concurrency inference scenarios that require larger model capacity. The third test used Google's Gemma 3 instruction-tuned model with 12 billion parameters and a model size of 23 gigabytes. At 50 concurrent requests, the processing speed was 0.64 requests per second, with a throughput of 449.39 tokens per second. When concurrency increased to 100, the processing speed slightly dropped to 0.62 requests per second, and the throughput decreased to 435.46 tokens per second. Compared to the 2 smaller models tested earlier, the 12 billion Gemma 3 model demands significantly more hardware resources. The 3 NVIDIA V100 setup exhibited noticeable bottlenecks under this configuration, with both inference speed and throughput dropping substantially. The final test evaluated the distilled version of the deepseek-ai Quen model, featuring 14 billion parameters and a model size of 28 gigabytes. At 50 concurrent requests, the processing speed was 1.07 requests per second, with a throughput of 479.70 tokens per second. When concurrency increased to 100, the processing speed improved to 1.71 requests per second, and the throughput rose to 820.05 tokens per second. Compared to the 12 billion Gemma 3 model, this 14 billion model demonstrated better performance under the same hardware conditions, with improved inference efficiency and throughput. This suggests stronger scalability, though it remains limited by available computational resources. Under the 3 NVIDIA V100 configuration, vLLM demonstrated its ability to optimize large language model inference performance in a multi-GPU environment. By effectively configuring tensor and pipeline parallelism strategies, it achieved efficient inference across models of varying sizes and concurrency levels. However, for ultra-large models with over 12 billion parameters, higher performance hardware is still necessary to overcome performance bottlenecks. Thank you for watching this video. Don't forget to like and subscribe. We will continue to bring you the latest cutting-edge updates.